Okay, so this problem says the following data shows the number of students on campus at the start of the semester and the number of parking spaces available in the campus parking lot. It says plot the data on the scatter plot below. It should be above. And I think on your paper it's actually below. So remember that with any graphs, the vertical axis needs to start at 0. So you can see that this counts up 0, 200, 400, 600, 800, 1,000, up to 1,400. And then but the horizontal axis, that one does not necessarily start at 0. So you can see there's kind of like a break right here, and this starts at 800. So when we plot these points, the top value is always going to be the x-axis, or the x value, and the bottom value is going to be the y. So these are actually, this is called bivariate data because you can see it is an ordered pair. So when I take a look at this first one, the x value is 1586 and the y value is 821. So what I'm going to do here is I'm going to find, so we're going to have to do a little guesswork here. So we've got 1,400 right here. We've got 1,600 right here. We actually should probably label this as students. So 1,500 would be somewhere in the middle. And then my y value is 821. So then I'm going to go up. Here's 200, 400, 600, 800. And then 21. Again, we're going to need to do some guesstimation here. But it's going to be somewhere around here. The next one was 2248 and 1044. So I'm going to go to close to 2200 and we're going to go up to 1044, which would be somewhere right around here. All right, so we got that one taken care of. We're just plotting points. These are corresponding to a single dot on this graph. 2615 and 1201. Here's 2600. It's going to be just right that. 1201 is going to be somewhere around here. All right, 644 and 1221. So 640, or I'm sorry, wrong way. 1221, 644. 1221 and then 644 is going to be somewhere. Sorry, it really doesn't like me drawing dots. There's that one. 3289, 1577. 3289. And then 1577. I think I'm going to have to go all the way up here. I don't even... Okay. And 2067 and 978. All right, 1058 and 554. All right, 3007 and 1547. Be somewhere up here. And 1138 and 566. Okay. So, I'm actually going to label this y-axis as well. Let's label that parking spaces. All right. Now, the next question says, does this appear to have linear correlation? What that means is, does it appear like a line could be graphed to start to track this information? And when you take a look, it kind of looks like it's pretty linear, right? Not exactly, but it looks pretty linear. So, does this appear to have linear correlation? We are going to say yes. And now the next problem says, what is the linear correlation coefficient? What that means is I'm going to go to my table And we are going to actually go to Excel and we are going to enter this bivariate data into the linear regression tab. So when you go in, we're going to put this data in. You can see we have a row for our X values. Those are the top values, and we have our Y values. So it's going to be 1586, 821. So I'm going to go ahead and hit pause. Why don't you guys put this in as well? All right. And you can see that this graph is pretty similar to what we have right there. And what it is drawing, it is drawing a predictive line right here. And you can see it's providing us our correlation coefficient, which is 0.99184. So let's go ahead and list that. This value is an R value, our correlation coefficient R. So we're going to go over here and we're going to list our correlation coefficient. R is equal to 0.99, what did I say, 18? 9918. And now it says, what is the regression equation? The regression equation here is a linear equation, which is listed right here. Y is equal to 0.46627 plus 40, well, actually, 0.46627, and then you see this X back here. Again, bivariate data always have an X and a Y, so we need to make sure we have that X, and then plus 48 point, we'll round this one 4 decimals, 0369. Okay, so our regression equation is Y is equal to 0.46627 X plus 48.0369. So this is a linear equation. We worked with some of these previously in the 013 course. So now it says, when do we use the regression value or equation? If we cannot use the regression equation, what is the predicted value? So we use the regression equation when R is greater than our critical value. And this is on the formula sheet. We'll talk about this more in class, but on the back of the formula sheet, you'll see a table of values. That helps us to determine whether our R value is strong enough to use the regression line or not. So if we use the regression equation, we'll use this equation right here when the R is greater than our critical value. If R is less than your critical value, use the mean of the Y values. Or another way to say this, we'll use another symbol, Y bar. Just like X bar is the mean of your X values or your sample mean, Y bar will be the mean of your Y values.